Hi students, welcome to HSC Earth and Environmental Science and Module 7, Climate Science. This is video number 3 in our little mini-series on natural greenhouse effects, and this time we're going to be looking at climate variation and volcanic eruptions. This is another component of the general idea around using secondary sources to assess different causes of natural climate variations and also the timescales over which they occur. And this time we want to focus specifically on some of the massive volcanic eruptions, particularly those that have been responsible for creating things like the Deccan and Siberian traps. We've previously talked a little bit about the LIPs, or large igneous provinces. Now these are continental flood basalts that cover very large amounts of continental space and are the result of often very sudden or short bursts of lava flows. These are mafic, and they tend to be associated a lot of the time with the orogeny, or the mountain building processes that are associated with the breakdown of the supercontinents and the redistribution of continents around the globe. So there is a link between what we're looking at here and what we looked at in the previous video on the supercycles. Specifically though, we want to talk a little bit about the Siberian, which is obviously a Russian example, and also the Deccan traps, and that's in a West Indian example. Now traps, I guess, before we go on, in this sense, trap I think has a Swedish origin and is identifying basically steps, a staircase, something like that. And so you see in the mountainside, you see these kind of steps, the layering that's very, very distinct. And there's some examples of it kind of in this region here. You can see them, lots of different examples of the Deccan traps in particular. You can see this kind of stepped arrangement. It tells you that you're looking at a trap. The interesting thing about both the Siberian and the Deccan traps is that they were the result of major eruptions associated with some significant changes in climate and/or mass extinction events. So in general, when we're looking at our large igneous provinces, we're looking at material that's come from deep in the mantle. So we are talking about mafic rocks, these very dark minerals, or rocks that are dominated by the very darker minerals of the mafic group. Their source is often these mantle plumes or super plumes, really large bodies that are moving up from the mantle towards the crust. And that are going to result in this burst of lava coming through and ejecting a great deal of ash and some pretty significant gases into the upper atmosphere. As I mentioned, the traps are these sort of step-like hills, the arrangement that you see very common in traps, and that's one of the reasons why they're called that. But one of the things that's interesting about the Deccan trap, the West Indian example, is its age is around about 65, 66 million years ago, which coincides with about the time that the dinosaurs, or evidence of dinosaur life, it disappeared from the fossil record. So is there a cause and effect thing going on here? We also know that there's a crater off Mexico called the Chicxulub crater, and that's been linked to the same sort of time frame, the same sort of time period. There seems to be some evidence that suggests that these mass volcanic eruptions were happening prior to the impact event that caused the Chicxulub meteorite crater. But there may have been an interaction between both of these events that has, I guess, had an impact on life that was on the Earth at that particular point in the Earth's history. What we do know is that these large igneous provinces are associated with these high levels of release of carbon dioxide and also some other gases which can be significant as well. Sulfur oxides, the SOxes, sometimes chlorines, that can be absorbed or dissolved into the rain and create acid rain. Now, this can have an impact on oceans and also very directly on global warming. So obviously, we're already talking about concerns that we have associated with increases in carbon dioxide levels and the fact that that is associated with increases in overall global temperatures. We also are aware of the fact, and you might remember this when we were looking at hazards in the previous module, that there can be some alternate effects. So the ash and the dust clouds that can be associated with these sorts of really significant sudden bursts of volcanic activity can actually have the impact of reflecting a lot of the sunlight and actually causing a short-term decrease in global temperatures. And then after that, the additional gases that have been there create a longer-term increase in temperatures, which is consistent with our understanding of the increase in carbon dioxide associated with what we're now referring to as the greenhouse effect. So one of the things that's very important when you are looking at these particular types of things, and again, we need to go into class, we need to start to pull some data together from, I've just kind of given you a very brief overview of some of the events associated with the Deccan Formation and when that might have happened and what other things might have been impacted at the time. But we need to have a look at that one in a little bit more detail, and also to have a look at the Siberian traps as well, to see if we can figure out how old they are, what sort of impact they might also have had on the environment. The thing to keep in mind, of course, is that this first part of our study of climate science is to try and give us a bit of an indication, our baseline, a bit of an indication of where carbon dioxide levels have been fluctuating naturally due to natural events that are occurring on the Earth, and the consequence of those increases or decreases in the levels of the greenhouse gases and what that may have meant for climates, ancient climates, over the history of life on Earth. So we need this very strong baseline. We also need to understand, as we've looked at before, some of the ways in which volcanic eruptions can have an impact on greenhouse gases and also other particulates and gases that are released into the atmosphere and what impact they might have on global climates as well. Thanks for watching.